On December 5, 1945, 5 U.S. Navy torpedo bombers took off from Florida for a routine training mission over the Atlantic. The flight was led by Lieutenant Charles Taylor, a highly experienced pilot. But within hours, Taylor radioed base in distress. He reported extreme disorientation, stating that everything looked strange and his squadron simply couldn't find west. Then communication went dead. All 5 bombers and their 14 crewmen vanished. The Navy immediately launched a massive search and rescue operation. 2 rescue jets sprinted toward their seaplanes to join the hunt. But before the day was over, those rescue planes vanished entirely too. In a span of just a few hours, 27 men were lost without a single piece of wreckage left behind. That single afternoon of cascading tragedy cemented a terrifying reputation for this stretch of ocean. If a highly trained military formation could be swallowed whole, anyone else flying through the area was vulnerable. This map outlines the region we're talking about, a 250,000 square mile expanse over the Atlantic. Over the last century, an estimated 50 to 100 planes have disappeared within these borders. While pop culture often looks towards the supernatural to explain these losses, the actual mechanisms are grounded in physical earth science. To understand what is actually pulling these aircraft from the sky, we have to look past the surface-level myths and analyze the region vertically, starting down at the bedrock of the ocean floor and moving all the way up into the stratosphere. We begin at the bottom of the Atlantic, beneath the triangle. Here, the ocean floor is shaped by the remnants of an ancient underwater volcano. This specific geological history left behind immense deposits of basalt rock. That basalt is highly concentrated with iron and magnetite. This animation shows the effect of those deposits. The dense magnetite creates intense magnetic interference that radiates upward from the seabed, directly interfering with standard analog navigational tools. Specifically, this local anomaly forces a compass needle to abandon the magnetic North Pole and instead point toward the geographic North Pole. For an aviator relying on traditional instruments, this effectively blinds them to their actual heading. This deep-sea geological trap aligns with the events of Flight 19. Lieutenant Taylor's reports of being completely disoriented and unable to locate west match the expected outcome of instruments being actively hijacked from miles below. Moving up from the solid rock into the water itself, the chemistry of the seabed presents a second hazard: methane blowouts. When massive pockets of methane gas abruptly release from the ocean floor, they create colossal bubbles that rush upward. This rapidly decreases the density of the water, which can instantly sink a ship floating directly above the eruption. As that highly concentrated methane breaches the surface, it enters the atmosphere. Once airborne, the gas can choke the intake of aircraft engines flying at low altitudes. In 1948, the passenger plane Star Tiger vanished. Investigators noted its unusually low cruising altitude, a position that, according to some theories, would have placed it directly in the path of any methane erupting from the surface. Later that same year, this DC-3 transport also disappeared. In this case, records suggest a battery failure likely compromised the plane's navigation, leaving the crew vulnerable to the region's environmental pressures. The ocean surface here acts as a volatile chemical barrier. A minor mechanical glitch or a sudden drop in altitude can quickly turn into an unrecoverable plunge. Ascending from the ocean's surface into the atmosphere, we reach the statistically most lethal layer of the triangle. The Atlantic Ocean functions as a hyper-engine for severe weather, accounting for the highest volume of disappearances in these coordinates. Take a look at this weather mapping data. Vast stretches of warm air act as explosive fuel, causing storms to intensify rapidly in the Bermuda Triangle. Gathering strength over thousands of miles, these massive systems presented an unavoidable, towering wall for mid-century aircraft. This creates a cascade of failure. A pilot already fighting a magnetically skewed compass or struggling with a failing battery has zero margin for error when their plane is swallowed by a Category 5 hurricane. Deep-sea magnetism and methane eruptions are documented dangers, but this concentrated, high-intensity weather is what reliably turns the airspace into a graveyard. The danger here is built in vertical layers, geological magnetic traps at the bottom, volatile chemical reactions in the middle, and massive storms churning above. These facts do not lessen the human tragedy of the crews who encountered these converging hazards without warning. Demystifying the Bermuda Triangle reveals a masterclass in extreme Earth science, a place where invisible, lethal natural forces demand total respect.